Hello everyone, welcome to my YouTube channel. In this video, let's solve one of the most popular lead code problem, that is product of array except self. So let's understand what exactly is the question. Here, given an integer array nums, return an array answer such that answer of I is equal to product of all the elements of nums except nums of I. So what here the question is, so we are given an integer array nums. So here in the example one, when we see there is a nums, right, which is an integer array that contains elements 1 2 3 4, right? We need to return an array answer. So in the output we need to return another array, which here they mentioned it as an answer, such that answer of I, so in the answer, whatever the value that is present in that particular index I is equal to the product of all the elements of nums except nums of I. So here what they are saying is like, that should be, let's say in the first example, let's go to the whiteboard. So what we are solving here, product of array except self, right? So when we see, they are given us a nums, an integer array which contains the values 1 2 3 and 4, right? So we need to return answer such that answer of I, right, is equal to the product of all the elements except this nums of I. So that means if I consider the answer of I, let's say answer of 0 when I is equal to 0, in nums I won't consider this element in I is equal to 0, but I will consider all the remaining elements, and if I do the product, that product should be the answer here. So that means 3 2 6 6 4 is 24. Similar with I is equal to 1 also. I is equal to 1. So that means I won't consider this value 2, but I will consider all the remaining elements and do the product, and I will return here. So that means I multiplied 1 with 3 and 4. That means the value is 12. Similar with 3, that means 4 2 is 8, and also with 4 it's 6, right? We need to return this particular answer. So, and also what they mentioned is like, so you must write an algorithm that runs order of n time and without using division operator. So division operation, right? So with the division operation, that means there is an obvious answer that we can be able to use with division, right? How we can be able to do? So let's say, how about if I multiply all the elements, so I will get one answer, right? So that means 1 multiplied by 2 multiplied by 3 and 4, that means I will get answer 24. How about if I, in the for every position, right, if I divide this value with this particular element, so that means 24 by 1, that is 24, then 24 by 2, that is 12, 24 by 3, that is 8, 24 by 4, that is 6. So here also we can be able to get the answer, but what they are saying in the question is like, without this division operation. That means we won't use this method, but how we can be able to solve this? In this scenario, think of a brute force solution. That could be our general for loops, right? Whenever we try to solve a particular problem, initially for the brute force, just consider the loops, right? The basic, without any considering uh, any optimization. So in the brute force, how about if I consider these values, right? 1 2 3 4, which is nums, and in the brute force, let's say for every value in the particular index, I won't consider this value, but I will consider all the remaining other values. That means I will consider two for loops. One for loop, it will it will consider every element and it will go till the end, right? So it will go like for int I is equal to 0 and I less than n and I plus plus, and also for I will consider another in loop which j is equal to 0 and j is also less than n and j plus plus. Why j is equal to 0 is because for this element, right, for this element 2 or 3, I need to consider from the very start, right? So that means I consider j is equal to 0, and in the condition that I shouldn't be equal to j, I not equal to j, then we can be able to multiply the values, right? So that means for this one, let's say for 1 2 3 4, right? So for 1 I will consider 2 3 and 4, that means what is the product, 24. For 2 I will consider this 1 3 and 4, so that is 12. Then for 3 8, for 4 it's 6, right? This is the output we need to return. So observe, for this particular uh, way, what could be the time and space complexity, time complexity and space complexity. So when we observe, what could be the time complexity? Time complexity is order of n square. Okay, why? Because here we are using two for loops, and every for loop here I will go till from 0 to n, right? This will take n and this will take n iterations, right? So n multiplied by n square, and the space complexity is order of 1. Clear? This is the brute force approach which we can think of. So can we be able to do try to optimize this to something better instead of order of n square, which is quite expensive? Can't we try to reduce this time? So in this scenario, there exists another variant of the solution. So here we consider nums, right, which is 1 2 3 and 4. How about, say, let's consider the value 3, right? So for at this position I need to consider all the previous values, right, and all the other value. I don't want this 3, but I need product of these values and I need the product of this value, right? So how about if I consider two arrays, two arrays, one deals with considering all the product values for every position in the left of this, whereas another array which considers all the product in the right of it, right? So here for every index, whatever the previous all values, we call it as like prefix, right? Prefix. And after whatever the that particular position, whatever the values that are after to this, we call it as like postfix or suffix, whatever it is, right? So pre and post, right? For every value there exists pre-values, pre-set of values, prefixed values, whereas there exist postfix values. Clear? So here if I consider a prefix array, let's say a postfix array, okay, and I found this array, and in the end I will return answer by multiplying this prefix and postfix. So let's understand how exactly we need to do. So let's say this is the thing, right? Nums is equal to, so 1 2 3 and 4, right? Initially I will start with index I. So I know there isn't any prefix values, right? So that's why for the initial condition I will consider this prefix of the first value should be 1. Okay, then I will move to the next index. So at this particular index I don't want to consider this element, I want all the previous elements. That means, so prefix is something which I calculate this sums, right, all the previous elements. So whatever the value that is here, that represent the multiplication of all the remaining elements except this value, right? So that means, how about for prefix, if I multiply for every index value, right? So that means, let's say prefix of I is equal to, how about if I multiply prefix of I minus 1 multiplied by nums of I minus 1, because in this position, that is I is equal to 0, I don't want to consider this one, I won't consider this one, but I will consider all the previous elements, right? So that's all the elements, that um, product is this prefix value, and for this element I should consider, for I is equal to 1, for this value 2, I won't consider this 2, but I want this 1, right? Whatever the value at this index position I is equal to 0, I want this. So that's why I multiplied this value along with the prefix value. That means at I is equal to 1, so what should I do? I multiplied by prefix of I minus 1, that is equal to 1, multiplied by 1, that is again 1. Now at I is equal to 2, so here I is equal to 2. Now what I need to do, I need to multiply prefix of I minus 1, right, which is the product of all the elements from here except 2. So that's why 2 multiplied by this one, so it is 2. Then again for 4, I will multiply 2 with the previous element 3, that is 6. Clear? I think prefix is clear, right? So why we multiplied by prefix of I minus 1 is like prefix of I minus 1, this involves all the previous elements, all the multiplication of previous elements except one particular element at the I minus 1. So for every I value, I multiplied these two values. I hope you guys understand. Then let's solve what is like how we can get this postfix. So observe postfix also. For 4, I don't have any postfix values, so for the initial condition sake, I will consider this value as 1. Okay, clear? So here what I need, how I need to get this particular value postfix. So here postfix of I, how I can be able to get, it's nothing but postfix of I plus 1 multiplied by, sorry, nums of I plus 1. Why I plus 1? Because can't we consider prefix? No, it's because at this position it contains this particular value 3, right? If I want at this position, if I consider this value, it includes this value 3, right? It includes the product of by having this 3 also. So I won't consider prefix, I won't touch this prefix. So with the postfix and postfix value and nums of I will get this. So postfix is like, it is also same like prefix, right? So this position, it will consider all the product of all the remaining other elements except the value at this particular index. So that's why here I need to multiply this one with whatever the uh, element that is present at this particular index of I plus 1, that is equal to 4. That means here the value is 4. Now what could be the value here? It is the multiplication of 4 and whatever the value at this index, it is 3, right? So 4 multiplied by 3, it is 12. And again at this particular index I need to multiply 12 with 2, that is 24. So how we can get the answer should be the multiplication of prefix and postfix, right? That means 1 multiplied by 24, it is 24, and 1 multiplied by 12, that is 12, then 4 2s 8, then 6 1s 6. So this is the output answer we need to return. Clear? So in this, what could be the time and space complexity? Time complexity, and space complexity. So observe here the time complexity is order of 3 multiplied by n, which results it's like order of n, and space is also order of n because I consider 3 arrays and for every value I'm going to and fro, right? So that means here for this value I will consider everything, right, from start to end, and for this value I will consider start to end, for this value I will consider start to end, right? So that means I'm iterating that n values 3 times for these 3 values, so 3 arrays. So that's why it's 3 multiplied by n, it is order of n. And similar with the space complexity, though same, we have 3 arrays, right? So 3 into n, that is, it simplifies, it's order of n only at the end. Okay, now so okay, this is quite good, it's order of n compared to the previous brute force approach which is order of n square. This is quite better, right? But think, can we be able to optimize this even more? So observe here we use 3 different arrays, right? Why 3? Can't we be able to do this answer how we did here in one single array? We can be able to do this, right? So that's why we got in solution 3. So how we can be able to do? Let's consider nums which is equal to 1, 2, 3 and 4, right? Now I will consider only the answer, not any other values, like here in the prefix and postfix I won't consider any, but whatever how we are doing in prefix and how we are doing in postfix, I will do the same here. That means like initially I will do prefix, right? So how we do prefix? So initially I as I don't have any other values prior this one, so I will take 1 here, and at this particular position what I need to do, I need to multiply these 2 values. So that means 1 into 1, which I will get 1, and for 3 I will multiply 2 into 1, 2, and then 3 into 2, that is 6, right? Here till now I solved the prefix part, right? Now for postfix, what I did initially here, I consider 1, right? But I had this value 6, so I want this 6 value also in the end. This is the output, right? Because I don't have any other values there, so whatever the multiplication that I got from here, it is similar to this, right? So that's why what I will do is, right, let's say I will consider another variable, let's say called right or value or something, whatever the naming is. Let's say I consider the value right, I consider it as right. So let's take this value 1. Okay, so for every index I will multiply this whatever the answer at index with right value. That means, so here 6 multiplied by 1, what I will get 6, right? So I make it as another just to make you understand, not to get confused. But so this is all this process we are done in the same one particular array only answer. Okay, now at this position, at what we need to do is, like, for every value we need to multiply it right with the nums of I plus 1. Okay, that is 4, right? Which we got the value 4. Okay, so this 4 I multiplied with 2, right? Here initially for prefix I multiplied by down, right? Up and down. Whereas for the postfix, what I will do is, like, I will multiply sides and I will consider this value. Okay. Give me a second. Okay, so here whatever the value that I got, right, which is 4, so I multiplied this with whatever the answer that I got, because observe at this particular position prefix is nothing but I multiplied this above 2 values, right? So that means 1 multiplied by 2, I got 2. Now I won't consider 3, but I need this value 4. So what I will do is like, so I will multiply 4 with 2, that is 8. So understand why I multiplied this, and for every value I will track that particular value. So that's why I consider right. So at this position what I will do is like, what will be the right value? Now right is equal to 4. 4 multiplied by what is at the nums value at this index, which is 3, right? 4 multiplied by 3, which is equal to 12, right? So now I multiplied 12 with, so that means I got this value. So 4 and 3. So I won't consider 2. So that's why I multiplied 1 with this value side, which is 12. Same here, which is 24, right? I think you got right how we got this. So this is what the answer, and we will return. And observe the time complexity here is order of n, as well as the space complexity. What could be the space complexity? Space complexity is, so it is order of n only if we consider this answer, because answer is another space that we are considering, right? And consider if I didn't consider this answer, okay, then it will be order of 1. But yeah, we do this, right? We will consider, so that's why it's order of n in my opinion. So yeah, this is how we need to solve. So let's get into the code, how we can be able to solve this. Okay, so initially let's consider, so int n is equal to, let's say, nums dot length. Okay, now I need to consider a result or output array. Okay, answer output, right, which is equal to new integer array of size n, right? Clear? Now initially what we need to do, we need to do a prefix part, so, and then we need to do postfix part. Okay, so at the prefix, what I said, whatever the value, the first value that is, right, so in the result of 0 I consider that value as 1, and now I will iterate for every value I is equal to 1, I less than n, and I plus plus I plus plus I equal to 1, right? So here what I need to, how I need to get result of I is equal to result of I minus 1 multiplied by nums of I minus 1. So that's what we did, right? So here how we will get, we will get the prefix of I minus 1 multiplied by nums of I minus 1, right? That is how we did. So here we don't have any prefix, but result we have. So result of I minus 1 multiplied by nums of I minus 1. This is how we got the prefix part, right? Whereas for the postfix, so what I consider another value, which is right or value or whatever it is. So for postfix, what I will do, I will start from the last index, right, n minus 1, and I should be greater than or equal to 0. I need to consider 0 also, right? So it is I minus minus. Clear? So whatever the result of I should be the value that is multiplied with right? And what right after that I will update right is equal to right multiplied by nums of I, right? So here what we did, so for every value of right I will multiply it with nums of I plus 1, right? So that's what I did, nums of I, and result was also like that. So after this, what we need to return? We need to return the output array result. Clear? So let's run the code. Yeah, it works. Let's submit. Yeah, we got it. So here is also they did the same. So instead of 1, so I directly consider the value 1 and multiply everywhere, right? So how here they consider result, whatever I consider result, right? So they consider postfix value as 1, and similar pattern they apply to the prefix also. Okay, so this is another way, and that's it guys. Thank you.